Welcome again. Today I want to talk about network topology. A network topology is the layout arrangement of the different devices in a network. A variety of physical and logical network layouts are in use today. As a network administrators, you might find yourself working on these different network layouts or topologies. Therefore, you must understand how they are designed to function. In this video, we review general network considerations such as the various topologies used on today's networks. A topology refers to a network's physical and logical layout. A network's physical topology refers to the actual layout of the computer cables and other network devices. A network's logical topology refers to the way in which the network appears to the devices that use it. Several topologies are in use on networks today. Some of the more common topologies are the bus, token ring, star, mesh, and hybrid topologies. Let's talk about each of these topologies. Bus topology, also known as a LAN topology, is a type of network topology in which all devices in the network are connected by one central cable. The single cable where all data is transmitted between devices. Maybe the cable is coaxial or RJ45. As you see in diagram, a bus topology uses a trunk or backbone cable to connect all the computers on the network. Systems and computers connect to this backbone using T-connectors. To avoid signal reflection, a physical bus topology requires a terminator. At the edge of the physical bus be terminated. Loose or missing terminators from a bus network disrupt data transmissions. The most common implementation of a linear bus is the IEEE Ethernet standard. Hub or switch is not needed in this installation. Some advantages and disadvantages of the bus topology are, compared to other topologies, a bus is easy and cost-effective to install and add or remove devices, does not require as much cabling as alternative topologies, works efficiently for small networks, and not use specialized network equipment. And some disadvantages are network disruption might occur when computers are added or removed. If the cable is damaged, the entire network will fail. Difficult to troubleshoot problems, very slow and not ideal for larger networks. Low security due to all devices receiving the same signal from the source, or like single broadcast domain. Ring topology. Ring topology is a type of network topology in which each device is connected to two other devices on either side via an RJ45 cable or coaxial cable. Or the ring topology is a logical ring, meaning that the data travels in a circular fashion from one computer to another on the network. Data is commonly transferred in one direction along the ring, known as a unidirectional ring. The data is forwarded from one device to the next until it reaches the intended destination. In a bidirectional ring, data can travel in either direction. In a true ring topology, if a single computer or section of cable fails, the signal is interrupted. The entire network becomes inaccessible. Network disruption can also occur when computers are added or removed from the network, making it an impractical network design in environments where the network changes often. As just mentioned, if a single system on the ring fails, the whole network fails. This is why ring networks can be set up in a fault-tolerant design, meaning that they have primary and secondary rings. If one ring fails, data can use the second ring to reach its destination. Naturally, the addition of second ring adds to the cost of the network as well as the complexity. Ring networks are most commonly wired in a star configuration. In a tokenic network, a multi-station access unit or MSAU is equivalent to an hub or switch on an Ethernet network. The MSAU performs the token circulation internally. To create the complete, the ring in port on each MSU is connected to the ring out port to another MSU. The last MSAU in the ring is then connected to the first to complete the ring. Some advantages and disadvantages of the ring topology are: ring networks are moderately easy to install. Since data flow in one direction, the chance of a packet collision is reduced. Devices can be added without impacting network performance, and also easy to identify and isolate single point of failure. Better suited for high traffic environments than a bus topology. And some disadvantages are: when all data traveling over the network must pass through each device or its way to its destination, which can reduce performance. If one device fails, the entire network is impacted. More expensive to implement than a bus topology. Star topology. In the star topology, all computers and other network devices connect to a central device called a hub or switch, and for that reason is sometimes called a hub and spoke network. Each connected device requires a single cable to be connected to the hub or switch, creating a point-to-point connection between the device and the hub or switch. In a star topology, the central hub acts like a server and the connected nodes act like clients. When the central node receives a packet from a connected node, it can pass the packet on to other nodes in the network. As you see in diagram, using a separate cable to connect to the hub or switch allows the network to be expanded without disruption. A break in any single cable does not cause the entire network to fail. The star topology is the most widely implemented network design in use today. Some advantages and disadvantages of the star topology are: star networks are easily expanded without disruption to the network. Cable failure affects only a single user. High performance as no data collision can occur. And it's easy to troubleshoot and implement. And also some disadvantages are: this topology requires more cable than most of the other topologies. A central connecting device allows for a single point of failure. The switch requires more resources and maintenance, and also it requires additional networking equipment to create the network layout. Mesh topology. The wired mesh topology incorporates a unique network design in which each computer on the network connects to every other, creating a point-to-point connection between every device on the network. In a mesh topology, there is no central connection point. Instead, each node is connected to at least one other node, and usually to more than one. Each node is capable of sending messages to and receiving messages from other nodes. The nodes act as relays, passing on a message towards its final destination. Some advantages and disadvantages of mesh topology are: mesh provides redundant paths between LAN topologies, and also the network can be expanded without disruption to current users. And some disadvantages are: it requires more cable than the other topologies, and also the implementation is complicated. Hybrid topology. Hybrid topology is the combination of two or more different topologies. It creates a redundant point-to-point network connection between only specific network devices. The hybrid mesh is most often seen in WAN wide area network implementations, but can be used in any network. Many of the topologies found in large networking environments are a hybrid of physical topologies. As you see in diagram, an example of hybrid topology is the star bus, a combination of the star topology and the bus topology. Some advantages and disadvantages of a hybrid topology are: this type of topology combines the benefit of different types of topologies in one topology. It's extremely flexible and reliable. This topology is used to create large networks and handles a large volume of traffic. It's easily scalable as hybrid networks are built in a fashion which enables easy integration of new hardware components. Error detecting and troubleshooting are easy. And also some disadvantages are: it's a type of network expensive. The design of hybrid network is very complex. And also usually hybrid architectures are larger in scale, so they require a lot of cables in the installation process, and installation is difficult process.